Hello, we're going to continue the lesson from yesterday, simplifying with exponents. I'm considering this part 2, but we're still just going to apply all the same properties that were discussed in yesterday's lesson and just do a little bit more complex problems and kind of emphasize the 2 comments that I mentioned in Google Classroom today, just making sure we distribute the exponent that's outside parentheses to everything inside the parentheses, and making sure none of our answers have a negative exponent in them. So today it's really just looking at practice problems. We've covered all the properties, and it's just how to use them with a little bit more complex problems, like I said earlier. So let's look at this first problem. We have the expression 10y in parentheses and a negative exponent outside it. So we have to make sure we distribute that negative exponent to everything inside the parentheses. So it's going to go to the 10 and it's going to go to the variable y. So it get written like this. We did the distributing, but now we just don't want to leave our answer with negative exponents. Since they're both negative, both the 10 and the y are going to move to the denominator, and now the exponents will become positive. Do you know what we'll put in the numerator? We kind of think of this expression as 10 to the negative third, y to the negative third over 1, kind of doing the reciprocal. So 1 would just be left as the numerator. That's the final answer. We could simplify 10 to the third. That would become 1,000. But after that, there's nothing more to do. As a rule, I generally tell students you don't have to simplify anything if the exponent's like 4 or 5, anything that or higher. You can simplify if the exponent's 2 or 3. Those are pretty simple. If you want to do it out, that's fine. You don't have to. All right, so that was our first example. Next one, what if we have a quotient all raised to an exponent of 2. So again, distribute that exponent to everything in the numerator and the denominator. So it would become 4 squared over n squared. They're positive exponents, so we don't have to worry about rewriting anything. We could just simplify 4 squared to 16. But there's no bases that are the same, so we can't combine anything. That would be our final answer. All right, so that's 2 problems. Let's step it up a notch. I'm gonna use this board. Some more room. All right, so let's look at another quotient. We have to do a little bit more distributing. All of that raised to the 5th power. So again, anything in parentheses, we have to distribute that exponent to everything. Everything in the numerator and everything in the denominator. So it's going to go to the 1, it's going to go to the 2, and it's going to go to the k squared. So the numerator, pretty straightforward, just becomes 1 to the 5th. The denominator, the 2 needs the exponent, and now the k needs it. So we have a power of a power. Remember from yesterday what we do with power of a power? We multiply the exponents. And then looking at that, we could simplify the numerator. 1 to any power is just 1. And you could leave your answer like that. If you wanted to do out 2 to the 5th power, 2 times 2 times 2 times 2 times 2, 32. So you could write 1 over 32 k to the 10th. I'd accept either one of these answers. All right, there's that one. Again, we had all positive exponents, so we didn't have to worry about rewriting anything. So let's take a look at another one with a negative exponent. So we have to distribute that negative 2 to everything in the parentheses. Give you a minute to kind of think about that's going to look like. So it's going to be 6 to the negative 2nd power, c to the negative 2nd power, and 7 to the negative 2nd power. So that can't be left right like that. Just make it more room. Okay, so anything with a negative exponent needs to move. These two have negative exponents and they're in the numerator, so they're going to move to the denominator. And then this is already in the denominator, that will move to the numerator. Then we can simplify anything to the power of 2. That's straightforward. 7 squared is 49, 6 squared is 36, and then we have c squared. So we just gotta look, 49 and 36, do they have any common factors where we could reduce that fraction? No, so that would be our final answer. All right, need a little more board space. So, just gonna do a couple more examples. Bump it up a notch. All right, so let's take the expression 2x to the 4th, y to the 3rd, and raise that all to the negative 2nd power. So again, we have an expression in parentheses, all raised to that exponent. That exponent has to get distributed to the 2, to the x to the negative 4, and to the y cubed. So I'll just start by distributing 2 to the negative 2. I have x to the negative 4th power, all to the negative 2nd power. A power of a power, what do? Power of a power, we multiply the exponents. And negative 4 times negative 2 makes a positive 8. And then we have y to the power of 3, all raised to the negative 2nd power. So we're going to again multiply those two powers and get negative 6. So can we leave our answer like that? No, because we have some negative exponents there. We only need to move the negative exponents though. This has a positive exponent, so we're not going to touch this. That doesn't need to be rewritten or simplified. So because that's positive, the x to the 8th is going to stay where it is, and then the other two values with negative exponents need to move to the denominator. So 2 to the negative 2nd will become 2 to the positive 2nd in the denominator. Y to the negative 6 will become y to the positive 6th power in the denominator. And I could just simplify 2 squared. So I have x to the 8th staying in the numerator, 2 squared is 4, and then y to the 6th. That's as simplified as we can get. Okay? I'll try one more with you, and we'll see how you guys can do. So let me just clean this board quickly, and let's take 4a all to the negative 2nd, b to the 6th, all over, a to the 5th, b to the negative 3rd. All right, lot going on there. What can we do first? Well, we have parentheses raised to that negative exponent, but we know we have to distribute it to everything in the parentheses. So we're going to have 4 gets the negative 2, and a gets the negative 2. B to the 6, all over, nothing to distribute in the denominator. So now I got rid of the parentheses. So I have a couple of things that need to be done. Negative exponents need to be made positive, and then I have some of the same bases here. So I can combine them, they're being divided, so I can apply the quotient property where I'm going to subtract the exponents. So let me combine my variables first before I take care of the negative exponents. So nothing to combine with the base 4, so I'm just going to leave that like this. Now my a's, a to the negative 2nd divided by a to the 5th. I need to subtract, so I got to think, okay, I'm subtracting those exponents. It's negative 2 minus 5. That's going to make a to the negative 7th. And then I have b to the 6th minus negative 3. Because remember again, we subtract our exponents if the bases are being divided. So this right here, subtracting a negative, I'm really going to add them, applying keep, change, change. So 6 plus 3 will make b to the 9th power. So at this point, I want to just rewrite anything that has a negative exponent. This does not, so that's not going to move down to the denominator. It'll just stay where it is, b to the 9th. But I'm going to move 4 to the negative 2nd to the denominator to make it positive 4 to the 2nd. And then a to the negative 7 becomes a to the positive 7. So again, I could just simplify that b to the 9th over 16 a to the 7th. And at that point, I have no parentheses left. I have no same bases. I have no negative exponents. That would be my final answer. Okay? So I'm going to give you some of these to try. Yes, they're going to be a little bit more challenging than yesterday, but you guys did awesome with yesterday's assignment. I think you're ready to step it up. I'm here to help if you need it. Good luck.